Section 1.5F, Homeostasis, the maintenance of blood pressure. So when we look at blood pressure, the set point there's a normal range of this, but as far as the set point, we're going to go with 120/80. It's okay for a little bit lower, it's okay for a little bit higher, but for this example, we're going to go with 120/80. In addition, we're going to follow the too low loop first instead of the too high loop. The too low loop makes more sense than too high loop, especially when you see what effectors kick in. Okay, so let's say, for example, instead of my blood pressure being 120/80, let's say it is 90/50. Let's say I have some sort of a liver laceration, and I'm bleeding internally. Okay, or maybe I'm dehydrated. Either way, my blood pressure is low. Let's say like 90/60 or so. Okay, well, we have specialized receptors called baroreceptors, and you'll notice they're not chemoreceptors, they're not thermoreceptors, they're baro. Baro means pressure, so they sense a change in pressure, and they're specialized cells that actually stretch in response to high pressure within blood vessels or relax in response to low pressure within blood vessels. So these baroreceptors sense something, and they send impulses through afferent sensory pathways to the control center. And the control center, in this case the brain, integrates and says, yo, our blood pressure is way, way, way too low. We've got to do something to fix it. So now, logically, the control center will then send efferent motor impulses to several effectors to help bring up your blood pressure. So now let's think about it. If your blood pressure is really low and you're not getting enough blood to the brain, you're going to start to feel lightheaded, weak, dizzy. You might pass out. Passing out is called syncopizing. So what can we do to jack up the amount of blood going to your brain so you don't pass out? Well, one thing we can do is we can get more blood to your brain if we beat faster. Another thing we can do is we can shunt blood to your core, which is your head, your chest, and your abdominal pelvic cavity, away from your arms and your legs. And when we do that, we actually direct or redirect more blood flow to the brain. And that's exactly what happens. So in this case, the effectors that kick in are we jack up your heart rate and we shunt blood to the core. So your heart's going to be beating faster and your skin's going to be pale because we're taking the blood that's normally distributed throughout your body and we're limiting where it goes. In effect, we're jacking up your blood pressure by redistributing it and making your heart beat faster. Okay? Now if we do that, hopefully your blood pressure will come back to normal. So now we should understand what happens when your blood pressure is way too high. The same baroreceptors pick up the information. They send impulses through afferent sensory pathways to the control center. This time the brain says, hey, our blood pressure is way too high. We need to fix it. Well, in order to fix it, in this case, the effectors are the exact opposite of when your blood pressure was too low. Okay, well, if you know too low, which is logical, now we know what too high is. So we're going to lower our heart rate and we're going to shunt blood to the skin. And in doing so, we're going to drop our blood pressure back down to 120/80. Okay, and when we shunt blood to the skin, we turn red or flushed, which kind of makes sense. When your blood pressure is high and you're arguing with someone, skin color turns red.